Hello and welcome to this online video lecture about significant figures. Significant figures is a method that scientists use and engineers to make sure that the entirety of a number as reported is actually meaningful. I think many times you guys have probably done a calculation on a calculator and it fills the whole entire display up with digits, and you always kind of are asking the teacher how many decimal places or how much of this number do I need to report. Well, significant figures is the answer to that problem, and scientists have been using this method for a very long time. So what it consists of is a set of rules for trying to decide what digits in a number are actually meaningful, actually mean something, and aren't just random garbage that got spit out by a calculation. By the end of this lecture, you should be able to determine how many significant figures a number has, and you should be able to report the answer to a calculation to the correct number of significant figures. Okay, so let's get right down to it. At its heart, significant figures is basically a rule set. There's a set of rules that you follow in your head when you look at a number to try to determine how many significant figures it has. And what I'm going to use here in this lecture is kind of a simplified version of the rule set. I'm going to explain it a little bit, but you can actually go out to the web. I'm going to link some sites in the course and maybe in the description of this video to some websites that each have a slightly different perspective on explaining significant figures, and you can kind of use whichever version you want. Some of them have more detail, some of them have less. So here we go. The first number, the first rule is that all non-zero digits in a number are significant. I'm going to abbreviate significant in the rest of this video lecture, SIG. So all non-zero digits are significant. So if you see the number, let's just say 1, 2, 3, that number has 3 significant digits or figures. So that's the first rule. The second rule, any zeros between significant digits are significant. Any zeros between significant digits are significant. So if you have a number like, say, 1005, you've got two non-zero numbers, and rule number 1 says that they are significant digits, and then you have 2 zeros between them, and so rule number 2 says that they are also significant. So that number would have 4 significant digits. And you might be noticing now that figure and digit is kind of used interchangeably when talking about these things. So that's rule number 2. So now the third and final rule that we're going to use for this class is that either a final zero or a sequence of trailing zeros, which means a bunch in a row, in a decimal. I'm going to scoot this up a little bit. And only in a decimal are significant. Okay. So if you have 1.50, that number has 3 significant figures. Because a final zero in a decimal is significant. If you had 2.000, that would be 4 significant figures. Because trailing zeros in a decimal are significant. So those 3, because they come at the end, one right after another, they're trailing zeros, they are all significant. You could have 25, let's say 250.000. That would have 6 significant figures. Because these trailing zeros are significant, the 2 and the 5 are significant, and that means that this 0 is between significant figures, so it is significant. So there's 6 significant figures there. So those are the rules for determining what is significant. Now what I want to do is I want to show you what's not significant. So if somebody wrote 2,500 and there was no decimal point, then these two zeros are not between significant figures, and they're not at the end of a decimal portion, and they are not significant. And so 2,500 written like this, 2,500 written like this, only has two sig figs. Oops, I'm sorry, I thought I grabbed black. 2 sig figs. 2 significant figures, the 2 and the 5. Those two zeros are not significant. Let's say I had the number 0.00230. Okay. Well, the rule says that this 0 is significant because it's the last 0 in a decimal portion. However, these zeros are not between significant figures. There's nothing over here that's significant. And they're not at the end of the decimal portion. So these zeros are not significant. These 3 zeros right here are not significant in any way. So this number right here would have 3 sig figs, 3 significant digits. So the reason why we have significant figures is because if you watch the lecture on making measurements, you know that when you measure something, all of the numbers that you record or report from a measurement need to be meaningful. So what you do when you make a measurement is that you report all of the numbers that are known for sure, for certain, and then you estimate one more digit. But that estimated digit still is meaningful because you're not just picking it at random, you're actually looking at what you're measuring and you're estimating what its value should be. However, anything past that digit would be random and unmeaningful because there's no way for you to estimate it in any way, shape, or form. So that's where these significant figures come from. They come from the measurements that scientists and engineers make. And we have to carry the significant figures over into calculations because sometimes when we multiply or divide or add or subtract, we get digits that are no longer meaningful because of the combination of numbers that we did the arithmetic with. So what we're going to do for this class is I'm going to go over the rules for addition and subtraction. The addition and subtraction has one rule, and the rules for multiplication and division, they have another rule. And then after that, you should be all set for significant figures for this course. So let's start with addition and subtraction. The easiest way to state this rule is that when you add or subtract two numbers, your answer has to have the same number of decimal places as the number in the problem that has the least number of decimal places. So answer must have the same number of decimal places as the number holy cow, did I mess that up? Okay. So your answer must have the same number of decimal places as the number in the problem with the fewest decimal places. So what does that look like? Let's say I was adding 1.372 to 2.6. So if you do this addition, you get 3.972. But using the significant figure rules, you look and you see that 2.6 has one decimal place, whereas 1.372 has 3, your answer needs to have the same number of decimal places as the number that has the least. So 2.6 has 1 decimal place, which is obviously less than 3 decimal places. So your answer needs to have 1 decimal place, which means that now you have to use rounding rules. So 7 is 5 or greater, which means that we're going to round this up. Well, what happens when you round 9 up? It rounds to 10. And so the actual answer that we're going to record here isn't 3.972, it's 4.0. So your final answer has to have the same number of significant figures, or the same number of decimal places as the number in the problem that has the least number of decimal places. That's the addition and subtraction rule. Let's look at it again. Let's say I had 10.75 minus, I said minus and I wrote plus, minus 2.263. Interesting. Well, this is a really tricky example. So what you have to do to actually do this problem is you have to pretend that there's a 0 here, but there is no measured 0 there. So you would do your arithmetic as normal. This would become 4, and you'd say that that's 10, so 7. You have to do this again, so 14 minus 6 is going to be 8, and then 6 minus 2 is 4, and then 10 minus 2 is 8. But now we have to remember that this 0 here, we just had to put that in there to finish the subtraction problem, and that this 10.75 had 2 decimal places, 2.263 had 3 decimal places. Our answer needs to have 2 decimal places. So we look and we see, we have 7, that's 5 or greater, so we have to get rid of that, and then our next digit has to go up. So 8.49 is the correct answer to that problem with the correct number of significant figures. So that's how you do addition and subtraction. Here is how you do multiplication and division. It's a little easier. Your answer must have the same number of significant figures as the number in the problem with the least. So if I was doing 2.5 times 3, and we get 15, here's 6, 7, we have 7.5, but 3 only has one significant figure. So since this is 5 or greater, we're going to round that up to 8, and that would be your final answer. The same thing happens when you divide. You have to look at your problem, and your answer has to have the same number of significant figures as the number in your problem that has the least number of significant figures. So those are the significant figures rules. As always, if you have any questions about those, please feel free to ask in class, and thank you for watching.